Today we are going to be speaking about multi-system installs, parallel stacking of the Sol-Ark 12K systems so you guys can get more power, especially peak power to power heavy items. Dylan Hillman, our engineering support manager, will be leading our presentation today. Whenever you call in and press 2 and get a hold of our engineering department, Dylan leads that team. So thank you, Dylan, for being with us and leading this presentation today. We're going to focus on some sales, but really today's presentation is more technical. For those who are new to Sol-Ark, new to solar plus storage sales, I still encourage you to watch and digest as much as you can. For those who are gurus, we hope this brings a lot of clarity to some things that might have been murky in the past, as well as allow you to think about opportunities that you can bring to your customers moving forward, how you can save money, and as well as other common applications, both residential 12240 as well as 208 volt commercial, light commercial. So perhaps you have customers that want to take their entire home off grid. Maybe they're building a new home in the middle of nowhere where they can't get the utility, but they still want the same creature comforts as a home in an urban area. Maybe they need a backup system because their business has, or their home has, sensitive electronics that they cannot glitch. We've talked about our no glitch switch, and that is extremely important to a lot of businesses. And when they want to tie in generators and back up all of their power, back up all of their electronic devices, this will allow you a really easy way to accomplish that. So without further ado, I'm just going to go through a short introduction about Sol-Ark if this is your first time with us. At Sol-Ark, we are a veteran-owned engineering company dedicated to helping families and businesses be less dependent on our vulnerable power grid in the most affordable way possible. We've been in business 7 years. We're tremendously financially healthy. We're accelerating our production and stacking deeper inventory during this COVID-19 time. We understand that's tough for some out there. We are all hands on deck, ready for you. Our lead times are very short right now. They're actually only 3 to 4 days. Call the nearest distributor in your area, or call us directly if there's not a distributor in your area, and we can get you Sol-Arks very quickly. We have, again, the Sol-Ark. It's the most efficient and affordable and powerful solar storage inverter in the world. We have received many awards for our technology, and we are now a 2020 semifinalist in the American Made Solar Prize for what we're developing on the utility side. So if you have any questions about our company, I'm more than happy to answer those. You can always call us at 972-575-8875. Press 1 for the business office. I'm more than happy to take care of you. Philip McIver also works with me, as well as Bob Nobry. Any questions about Sol-Ark, more than happy to take care of you. So with that said, I'm going to hand it over to Dylan Hillman, our engineering support manager, to dive more deeply into stacking Sol-Arks. Dylan.
All right. Yeah, thanks, Andy. So today's agenda, I'm going to start out with some relatively basic stuff. Why would you want to stack systems? What does it do for you? How to program which systems are master and slave. And then we're going to get a little bit more detailed and jump into some wire diagrams, programming, and some frequently asked questions that we get a lot about paralleling. I do recommend, if we have some veteran installers here or people that are just now getting into the paralleling of Sol-Arks, especially for three-phase applications, please do pay extra special attention. The way that we have it in the manual and the way that we've described three-phase stacking before has been altered. And in some cases, it's a fairly significant alteration. So we will be updating the manual available on our website here in the next couple days. And then the information in these slides are up to date as well. And then at the end here, I'm going to have Andy give you some information about where you can buy Sol-Arks, where they can be found, and all that good stuff. And we'll wrap it up with a Q&A session. Also, as I'm going through these slides, I will try to keep an eye on the chat. So if you do have a question about something that I'm currently talking about, please put that in the chat, and I'll do my best to answer it as we go. So let's jump right in. So why stack? There's pretty much two reasons. You want to have more power available, so like more solar panels, more power output, or you're trying to do true three-phase 208 battery backup for your loads. So we'll jump right in. Stacking at 120/240, you're going to be able to do that with 1 to 8 Sol-Arks, so up to 8 Sol-Arks, including all the ones in between there. And the continuous power is going to stack exactly like you think it would. So if you have 2 systems, you get double the continuous, so on and so forth. But the peak power doesn't stack quite like that. You get a little bit less peak power per system the more systems you have in parallel. And here we have a little bit of a quick explanation of how that works. So instead of the 20 kW that you normally get per system if you have one system, with 2 systems you'll get 18 kW peak for 5 seconds per system. So you get a total of 36, and then so on and so forth as you go through with more systems. It is a fairly linear relationship between them as you go. And for convenience and reference, I went ahead and made this chart for you guys. So if you want to know exactly how much continuous on-grid power, off-grid power, pass-through, etc., that you'll be getting with a certain number of systems, this slide here might be a good one to keep for future reference. Just only quick notes here on this is that notice that when you get up to 8, your maximum values here are going to be continuous on-grid value. This is how much power we can sell to the grid when the grid is up. This is 9 kW per system from the solar panels to the grid. Bear in mind, we are the 12K unit, so we can do an additional 4 kW per system to the battery bank, but I figured these values were more pertinent to most installs. The off-grid value here is going to be 8 kW per system, and linearly, like I said before, so that stacks up just like you think it would. Pass-through is 12 kW per system, also stacks just like you think it would. And then the peak power, as I mentioned before, is a little bit different, so keep an eye on that. Right, so Masterslave Assignment. With 120/240, it's pretty simple. Your first system is the master unit, and then all other subsequent systems are quote-unquote slave systems. So the Modbus addresses that you'll give each system do need to go in order, and you cannot skip any. So if you have 3 systems, you can't go 1, 3, 4. It's got to be 1, 2, 3. So that's pretty straightforward there. And here we're going to get into something a little bit more complicated. Oh, I have a question from Lance. Can they not output 9.6 kW each? They're capable of that, and we were doing that for a little while, but we had to limit that to 9 kW in the software for regulatory reasons. So it's going to be 9 kW continuous to the grid on the AC side going forward per system. Good question there, Lance. Okay, so this diagram here, there's a lot to look at, but really what's going on here is you pretty much just have one master system, and everything else is going to be in parallel. So the battery bank is in parallel. Both systems have their own connection to one big battery. The load-outs are all paralleled to go over to our bypass switch here. AC inputs to the grid, also just in parallel to a bigger grid connection. Usually you can do like an AC distribution panel or a junction box, or I have some other suggestions on the hardware later on in the slide for doing this distribution. And then if you have a generator, a quick note on that, it does need to go to all units in question that are in parallel in the same way. So if you're going to be hooking a generator up on the generator port, it needs to be hooked up to the generator port on all systems in the same way. So keep your phases straight. The parallel systems do have a communication cable that goes between them. You can use either the leftmost or the middle slot here for the paralleling communication cable. You cannot use this far right one, and these 2 up here at the top are only used for lithium battery communications, which I'll get more into later on. I have a question. Can I move the PV disconnect? I want the Sol-Ark directly on top of the 8-inch gutter box. The PV disconnect, unfortunately, cannot be moved. It is built into the unit. I won't be able to move in that. But okay, so CT sensors, something to note on that is that whenever you're doing 120, 240 volt stacking, all sensors go to the master system. So your temperature sensor, communications with the battery, if it's supported, your CT sensors, all that stuff is going only to the master and nothing to the slave units. All right. And then this is basically the same thing but with 3 systems. So just scale it up a little bit. Everything else is the same. We do recommend this bypass switch over here because if you have this many units in parallel, if you have to do a software update or modify some of the wiring or something along those lines, it's really nice to be able to just switch it over to the grid if need be. And then also, when you have this many systems, in most cases, you can back up the customer's whole panel. So, you know, we like to do it this way. The only other thing here is 2-wire start also goes to the master system. That's pretty much it. These fuses down here, just a quick note on those, these are only required if you have 3 strings per MPPT in parallel. I have another example coming up in a little bit where you don't need those fuses if you have less than 3 in parallel. So stacking at 120, 208 for 3-phase, you can do 1 system if you're only doing 2 legs for connecting to a 3-phase power supply, but you don't get true 3-phase battery backup. You just get 2 of the 3 phases with 1 system. 2 systems, you get true 3-phase backup, but it's unbalanced. You'll have 1 leg that gets more power than the other 2. And then 3, 6, and 9 are going to be true 3-phase balanced backup. So, and same thing on the power stacking. Continuous power is going to stack linearly just as before, except for those 2 caveats that I mentioned before with 1 and 2 systems. And then the peak power is going to stack the same way as well. And here's a handy-dandy chart for that as well. So again, if you have 1 system, you get 2 legs only. If you have 3 systems, you get everything. Or sorry, 2 systems, you get 1 leg that's a little bit unbalanced, so 4.8, 4.8, 8.4 in terms of their peak continuous power there. And then the rest of this is good for reference. Oh, I see a question here. Do stacked paralleled systems carry all the same certifications as individual inverters? If not, can you summarize the differences? Stacked parallel systems do have all the same certifications and operate accordingly. You just have to scale up everything to the amperages involved for however big your install is. And let's go ahead and go on. So Masterslave Assignment for 120.208 is going to be a little bit different. So when you have 2 systems, they're both going to be a master. And when you have 3 systems, all 3 will be a master. CT sensors will go to the first 2, and I'll show this again with a diagram later, but whenever you're using just 2 units or 3 units, the first 2 legs for the CT sensors go to the first master, and then the third sensor will go to L2 of the second master. Also, just a quick note on the auto-learn CT function that we have built into the Sol-Arks. 1, it only works with batteries, and 2, it's only going to be able to learn the CT sensor's direction. It's not going to be able to correct for it being on the wrong phase. So please make sure to keep the phasing straight while you're doing your install. All right, so for 6 units, you have kind of an alternating pattern here. So you've got a blue team, a red team, and a gray team here for your Masterslave assignment. So your Modbus address 1 is going to be master for phase A. Modbus 3 will be master for phase B, and Modbus 5 is going to be master for phase C. And same thing, you scale this up if you go to 9 systems. So again, the Modbus address for each master is going to be different here, but the same idea propagates. So blue team is still going to be this guy, red team is still going to be this guy, and gray team is this guy here. I have a question here. Have you seen insulated splice knuckles used to do connections between inverters? Yeah, actually, I have a photo of one of those coming up in a slide later on. All right, quick wire diagram here. So this is going to be that special case where you're using 2 systems for 3-phase backup, where you're going to get unbalanced a little bit more power on one leg than the other two. CT sensors are going to be shown just like this. So again, Master A, L2, Master A, L1, and Master B is going to get the L2. It's actually not shown right here, but there's a nice little chart here, a key, that kind of clarifies that a little bit. Everything else is going to be pretty straightforward. So you've got, phase 1, 2, and 3 over here, and then you've got 1 and 1, 2 is by itself, and then 3 is by itself. So this L2 input on the first system is going to be the one that gets double the power available per its output. And then the rest of the stuff is just as before. So all the sensors are still going to go to Master A, with the exception of that one CT sensor. Battery communications and all that are still going to go to Master A. And then here's that drawing of not needing those fuses on the PV side. So if you only have one or two strings per MPPT input, you no longer are required to have fusing per string, so that can simplify things if you can get it down to less strings. All right. And here's just a little bit more complicated of an example with 3 systems for totally balanced 3-phase. And again, all these diagrams are going to be in the newer version of the manual that will be released here in a few days for reference. And then this slide deck is also going to be made available to you guys. So don't feel like you have to memorize this real quick. But again, so with 3-phase here, you're going to have 2 inverters helping on each leg for a balance of all 3 legs. And notice here that there's 50 amp breakers on each of these, but they're 2-phase 50 amp breakers. So technically with 3 systems, you're going to have 100 amps of pass-through per leg. Just a quick note there. And everything else here is going to be the same. So you've got your fusing down here because I showed more panels here. Everything else is going to be very similar, except for one quick note on PV rapid shutdown. When you have more than a couple systems, for rapid shutdown, I recommend getting a external 12-volt power supply to power all of the transmitters that you're going to have, because you'll have a transmitter per Sol-Ark whenever you have multiple systems. So if 3 or more, I'd say go ahead and get an external 12-volt power supply for those if you're using something like a Midnight or a Tigo transmitter, because you can't parallel the outputs of our built-in rapid shutdown power supply between units. It has to be a bigger external one if you're going to do multiple transmitters. All right, I'm getting a few questions here. Should we be using a shielded Cat6 cable for paralleling? So the Cat6 or Cat5 cable that is included in the box with your systems usually is good enough, but occasionally we have run into a few interference issues. If you have that, wherever you get a kind of a random parallel communication fault, or like an air switch fault, as sometimes it'll give you, if that is an indication sometimes that you're getting some interference. To keep that interference down, you make sure that you use the toroids that are included in the box on the battery cables. That can keep that interference down. But if you continue to have problems, yes, I would recommend getting some shielded Cat6 cable for this parallel communication line between Sol-Arks, and making sure that the shielding is grounded. That will alleviate that issue if it comes up for you. Let's see, is it necessary to switch the neutral and the bypass switch? No. You can just have the neutral directly hooked up between the 2. All right. System layout. So when you're putting systems next to each other, the minimum distance is going to be a foot between systems, and that's for cooling reasons. I personally recommend if you have the space, 18 inches is preferred for better cooling, but 12 is the minimum. And then, of course, these systems are indoor rated only, so they're NEMA 1, so keep that in mind. Let's see, I got a question here from Mark. The wire diagrams in the 12K manual, when stacking 12240, it does not show any AC coupling. Can you AC couple when stacking multiple Sol-Arks? Oh, well, oddly enough, this slide right here is about AC coupling with multiple Sol-Arks. So On the load side, if you're AC coupling on the load breaker of all these systems, since all the load breakers are in parallel anyways, it's going to act just like it regularly would. So we have the frequency curtailment just like we normally would. You can do 9.6 kW of AC coupled power on the load side per system. So, and this stacks linearly as well. So if you have 2, you get 2 times 9.6. If you have 9 of them, you have 9 times 9.6 for load side AC coupling. Now, gen side AC coupling, which if you can do load side, I'd recommend doing load side with multiple systems, especially on much larger installs. But if you go with the gen side AC coupling, it's going to be 7.6 per system per usual. And the way that the relays are going to work is basically they're all going to happen at once. So whenever we have this AC coupling on the gen side is driven by the SOC of the battery bank. So if you're triggering the AC coupling to stop, it'll try the frequency curtailment first, but if you do it on the gen side, it still has a relay in there if need be. You can physically disconnect the AC coupled panels as well. And then DC coupling is it's exactly the same as if you had one system per system, because they're all independent. So each system has its own 2 MPPTs, 500 volt input. We can do 18 amps at 500 volts or 20 amps at 450 volts or less. And that's going to be just like it would be for one system. So just multiply all that stuff. Okay, so here's that photo of an example of a nifty device for paralleling the outputs. These are called Multitap kits, I believe. You can also use a regular AC distribution panel or a junction box of some kind there, but these are really popular for doing this for medium-sized installs. So definitely take a look at those. And some other quick notes are that if you're going to do an install that is, I guess, really 3 systems or bigger, I highly recommend asking for a blue board, Sol-Ark 12K. So there's a few iterations of hardware out there. There's some green boards and there's some blue boards. And the blue boards have field replaceable relays, and they're also a little bit faster. So the green boards are going to have like an 8 millisecond transfer time, whereas the blue boards are going to have a 4 millisecond transfer time. And that really helps the stability of the system as you get to the larger installs. So highly recommend taking a look at that. Generators must be connected. I think I mentioned this before, but it is very important. So if you have a generator and you have multiple systems, please connect that generator to all systems in the same way. So if you're using the grid input for an off-grid install for the generator, use the grid input on all systems in parallel, and keeping all your phases and stuff aligned as well. And then a quick note on your battery bank. So you do need to have one giant battery for all your systems in parallel. So that means that all the connectors for the parallel batteries, so if you have like 5 batteries in parallel, we recommend using bus bars for the parallel connections, because you're going to need to have that bus bar be rated for whatever the maximum discharge is for the total system size. So it's going to be 185 amps per system. So the bus bars can potentially get pretty large on some of these bigger installs. So let me see if I get some other questions here in the chat. Power distribution blocks. Polaris. Oh, okay, that's a good recommendation there. Engineer 775. Okay, so how many batteries do you need given your loads and system count? Well, some lithium batteries that have higher capacity outputs, so like 1C would be their amp hour rating, is their output, maximum output, so 200 amps in this case for a 1C, or 400 amp hours at a 0.5C rate. This is going to determine the minimum battery bank size to get the maximum performance of your systems. So you're going to need the battery to be capable of outputting 200 amps to each Sol-Ark. And then the minimum to have the systems operate as if they were off-grid is going to be 50 amp hours per system. So, if you have 3 systems, you need 150 amp hours at least. I don't recommend having a battery that small per system, but a lot of folks like to know whatever the minimum is, and so there you have it. And then the maximum battery size is going to be 9,900 amp hours, which is basically as big as you want. That's basically, that register won't allow you to program it to anything bigger than 9,900 amp hours. That's basically just all that is. And I'll get into a little bit more on how that's programmed here in a moment. Actually, I guess right now. So the battery capacity is basically only going to be programmed on the master unit. So you're going to have the battery capacity here on the master for phase A, if you're doing a 208 install, or just the master for 120, 240 installs. You'll put the whole battery bank size here. But the rest of these values for charge and discharge, both for this menu and the charge tab as well, you're going to divide that by the number of systems you have. So if your maximum discharge for 2 units is going to be 50 amps for your battery bank, or 100 amps for your whole battery bank, you would make each system charge and discharge at 50 amps. So whatever it is there, it scales per system. So you divide it between the systems for your charge and your discharge rate. Your temperature coefficient, that's going to be shared with all the other systems automatically. So you just set that up on the first master unit, and it'll propagate that information throughout. Same thing with these settings here with percent charge and voltage charge, all that good stuff. That'll propagate. Battery comms. So we are working with a few battery manufacturers to have communication in real time with the BMS for some lithium batteries. So in May, we're hoping to have Discover and Blue Ion, and in July, we're hoping to have Fortress. And basically what it'll do is in real time, it'll program the master unit, and then the master is going to propagate that information to the other systems in real time. So all these values that you see here, so your capacity, charge current, battery empty voltage, all that stuff, it's going to be programmed in real time from the battery that we're connected to. And again, that's only going to be connected to the master for phase A. And a quick note on these phases, you don't need to program any phases for 120, 240. It's only for the 208 installs that you have to assign phase A, phase B, phase C. I have a quick question here. Can go 16 equals, 16S battery bank, I believe he's asking about for lithium iron phosphate. So we do have 2 hardware versions out in the wild. Most of the ones out there right now are going to have a maximum charging voltage of 59 volts, but we do have a newer hardware version available if need be. They can go up to 63 volts for its maximum charging voltage. So I don't know if that's 16S off the top of my head, but there is some leniency there in your maximum charge voltage. All right. So how to program, some more programming settings here. All these values are only needing to be programmed once on your master unit, and it's going to copy all this information over to the other units respectively. So I went over these in the previous webinar, so I won't go into it too much, but basically they all propagate, so that's pretty cool. This one will propagate as well. This is very important, though, if you only have one system. Just as a refresher, battery empty voltage is used to prevent damage to the battery and the inverter. If we hit the battery empty voltage under a load, we'll turn the inverter off first to protect all parties involved. Very important. We also use it as a floor for the battery SOC calculations. So if you hit this battery voltage, we will reset our SOC calculation at 0 whenever we hit that point. And then a quick note is, again, this is going to be overridden if you're using a battery communication, compatible battery with communications to the master unit. It'll program this for you. Just a quick note here too, the generator charging is again going to be split between each unit. So if you can only charge at some amperage per system, just divide it by however many systems you have for what your generator can do. If you are using a generator connected to the grid input of the systems, you do need to select Gen Connected Grid Input, and please make sure that this is selected on all units in question. And then your frequency range, we also recommend that you widen that if you're going to be using a generator, because they do tend to have a little bit dirtier power, so you'll have your systems will be more likely to stay connected more often and more easily if you widen this frequency range. So we do recommend doing that. As well as selecting this general standard mode here. The default mode is going to be UL1741SA for you guys. So if you have a big generator, go ahead and switch it to general standard. Peak shaving, specifically peak shaving and gen shaving with regard to parallel systems. You will only set this up on the master A unit, and it is done in wattage. So total wattage either for 2 phases if you're using 12240, or total wattage for 3 phases if you're using a 208 install. And you're going to divide whatever your threshold value is by the number of systems that you have. So if you want to keep it below, your threshold is 9,000 watts for a 3-phase install, and you have 3 systems, then you would set your threshold value here in the System Setup Advanced tab to 1/3 of that. So you'd have 3,000 per unit, just as an example. So again, that's going to be divided. Same thing for the grid, the generator, peak shaving, same thing. Auto detect limit sensors, again, you do need batteries for that to work. So if you don't have batteries, you're going to have to make sure you get it right the first time for installing the limit sensors, instead of being able to learn their orientation after the fact. And then for your time of use settings, actually I think I have another slide on that coming up here. Yeah. So time of use settings, these will propagate to all other systems. And again, for this wattage here, you're going to divide by the number of systems that you have. So you have 2 systems. The total system's performance is going to be 4,000 watts in this example instead of 2,000, so 2,000 per system. All these grid charge, gen charge, timing, all that stuff propagates to all systems, so you don't have to put that in, 5, 6, 7, 9 times. And then, yeah, I guess just a quick explanation of how this works in case, just a little refresher here. This is going to use 2,000 watts per system starting at 1 a.m. until the batteries hit 40% to offset the power in the home. And then during the day, it'll still try to keep these batteries charged as high as it can and sell any extra power to the grid. Okay, quick note on smart loads. If you have a whole bunch of systems in parallel, the smart load output per system is independent. So if you had 3 systems, you could have 3 independently programmed smart loads. So you could have it, see how these values up here in the upper right. Your smart load off battery is at 80% and on is at 90%. So you could have different on and off values per system per smart load. So you could have however many you want going on. It adds to the amount of control that you have for automatic load shedding times the number of units that you have. So just pretty cool there. Otherwise, everything else is the same on how that works with just a single system install. So some FAQs here. Which systems do the CT sensors connect to? I get this one all the time, and I have covered a little bit here, but let's go ahead and do it one more time. 12240 volt installs only the master unit with Modbus address 01 is going to get the CT sensors. And then for 208 installs, the first 2 go to master A, and then 1 goes to master B. So the master B is going to be the L2 only on that input. And they're labeled in the little bus bar that you plug them into on the circuit board. And then this next question here, can I use separate battery banks? So no, you can't. All batteries need to be connected to each other in parallel. You can't have like 2 20 kW kWh batteries on the first 2 systems and another 2 on the second 2 systems. They do need to be all in one big battery bank of 4 20 kWh batteries that are being fed to each system with their own connections. So usually it winds up being a 2 aught AW wire to each Sol-Ark for the battery connection, and then some beefy bus bars between each battery in parallel. Let's see, and then battery temperature sensor placement. The placement of it, you can usually just tape it to the side of the battery or in between some batteries. It has no polarity. It's also not needed if you're using a lithium battery or lithium battery communications. And then, again, it's only going to go to the first master unit for that the temperature sensor. I have a question here. Can master gen connection be tied to gen while slave gen output is programmed as smart load? No. It's one or the other. So if you have a generator connected to the gen import here, you're going to have to select use gen input as a smart load output over here in your smart load settings, and that will take up this slot. And you can only, if you have a generator and you want to have smart load as well, the most common way to get around it is to put a transfer switch on the grid input side, and then you can have, whenever the grid goes out, it'll switch over to the generator to feed the grid inputs of all Sol-Arks in question, and we will detect the difference automatically and treat it accordingly, but that's a way around that. Also, a quick note, if you're AC coupling, it always takes up the gen slot also, so you can't AC couple and use smart load. If you're AC coupling on the load side, even though you're not connecting to the generator input breaker, it still occupies that slot in the software, so you cannot use the generator input with any kind of AC coupling, whether it's load side or gen side. So quick note there. All right, so with that, I'm going to give it over to Andy for a little bit here to get some information on where to get your Sol-Arks, and then we'll wrap it up with some Q&A at the end. Andy?
Thanks, Dylan. Guys, I know there are a few questions that Dylan didn't get to. Thank you for being patient. We'll get to those in the Q&A portion. So where to get more information about what Dylan has spoken about, just go ahead. You guys can contact us anytime, 972-575-8875. For technical questions, you can press option 2, but if you're just interested in moving forward and getting Sol-Arks or have general questions about our company, press option 1. That will get you into the business office. Either I or Philip or Bomner or somebody in our business office will take care of you. Please go to our YouTube channel. We have a ton of awesome content. It's packed with information. I really encourage companies that have new staff, send them to our YouTube channel. Say, lock yourself in a room for a day and binge watch everything that Sol-Ark has. They will come out knowing a whole lot before you send them into the field to sell. New crews wanting to get trained up, watch Dylan's videos. Tom Brennan, our head engineer, also has excellent webinars on battery chemistries and certain installation tips as well. So if you have questions, you can always email us as well at support@sol-ark.com. And if you have sales questions, sales@sol-ark.com. And if you're interested in signing up, of course, you can go to our website, and in the top right-hand corner, there's a sign-up button. If you'd like to join our reseller program, if you haven't already, go right ahead and do that. It's a very easy one-page form, and that will get you taken care of, so that we can reach out and make sure that we answer any questions, have a profile for you in our system, and you can also let us know if you have a preferred distributor in your area that perhaps is not yet carrying the Sol-Ark that you would like to carry it. Okay, so on to Q&A. Yes, are we still open? We talked about that earlier. We are open, again, operational, adding production and inventory. We are here for you during this tough time. Our lead times have actually shortened. So if you have some urgent jobs, I got calls from customers earlier this morning actually that they were actually able to close a couple because during this uncertain time, some customers wanted to get a Sol-Ark pretty quickly.